Welcome back to Section 5, Lesson 1, Writing and Solving Equations. Here we're going to look at solving equations using algebra tiles. So here we have a long rectangular tile, which will represent a variable, like x or n or whatever variable is in the equation. Then there's also a smaller square tile, which represent a unit, like 1. So let's have a look. Say you are trying to represent 2x plus 3. That would mean you would need 2 of the longer rectangular tiles and then 3 small square tiles. Now what expression is being represented here? You count them up. You count 4 of the x tiles and then 7 of the unit tiles. So you put it together to be 4x plus 7. Now, when you solve equations, you can think of an equation like a set of balance scales like you see here. Right now, I have an x tile and a unit tile on the left, and I have 4 unit tiles on the right. Now, what would happen if I were to remove a unit tile from the left? Well, the scales would tip, meaning the equation is not equal anymore. So to fix that, I can remove a unit tile from the right to make it balanced again. Now we do this because in order to keep a scale balanced, you have to do the same thing to both sides. You have to add the same amount or subtract the same amount from each side. So we're going to use the same approach when solving equations and make sure that what we do to one side of the equation, we do to the other side of the equation as well in order to keep the equation equal. So now in this example, it says solve each equation using algebra tiles and then verify your answer. So we'll start by representing x plus 3 with the tiles. So I have 1 long tile and then 3 small squares. Then for the equals, you can just draw a line to show you're dividing the 2 sides. And then 6, I need 6 small square tiles. So this is the equation x plus 3 equals 6 represented using tiles. So now, how do we solve for x? To solve for the variable, you always want to isolate the variable tiles on one side and the unit tiles on the other. So if I want to have only x tiles on the left-hand side, I'm going to need to take away 3 of the unit tiles on the left. But now we got to remember the idea of the scales. I just can't take away 3 tiles on the left. I also need to take 3 tiles on the right as well in order to keep my equation balanced. So now if I were to take those away, this is what I'd be left with. So your next step is to arrange the tiles in equal rows. So that would look like this, where everything is in one row. So one of the rows, in this case we only have 1 row, but in some cases you would have multiple rows. So one of the rows that you have will be the answer. So now what do we have here? On the left we have x, and on the right we have 3. So x equals 3 is the answer. Now the question also wants us to verify. So let's go ahead and replace x with 3 in the equation. So we have x plus 3. Replacing x with 3, we just get 3 plus 3, which is 6. Now if you look at the equation, that's what we have, so that means we are correct. Now let's look at 2x plus 4 equals 12. So we start off by representing 2x plus 4. So that would look like this. Now we need 12 of the unit tiles on the right. So here is the equation. So now we have to isolate the variable tiles by removing the unit tiles, the same number of unit tiles from both sides. So on the left, I'm going to take away 4 of these unit tiles. So that means on the right, I'm going to take away 4 as well. So if we take those away, this is what we're left with. Next, we arrange the tiles in rows. So if we do that, we would get this. 2 of the x tiles, and if I arrange the tiles on the right, I'd have 4 in each row. So now one of the rows would be the answer. So we have x equals 4. Now to verify that, let's replace x with 4 in our equation. 2 times 4 is 8, plus 4 is 12. Now since that matches the equation, we are correct. So that's how you can use algebra tiles to help you solve equations. You can now move on to the next video in this lesson.